All right, so what we're going to do now, let's bring everybody back on. So, we got Lake back on and Billy and Keith. And again, Ben, thank you very much for your presentation. That was very well done. And we do have some more questions here for you. We'll just bring the whole crew back on here. And
nice to have.
This was a great day. I mean, to have you guys do what you did for us today. I mean, you literally spoiled us. And we realize that all of us. I mean, we're located all over the country here. So to put this together with technology and everybody's time, it was very well done, and a lot of really good information. So there you guys are for sure. So everybody's back up there.
Getting the band.
What I'll do now.
No mute now. Okay. Hey. So
there you go.
Talking, right. So I have a question for Ben. Okay.
Oh, I
so
thought you were taking
it. Right. So yesterday I was dynoing or trying to break in that 250cc. I know I'm looking at I'm looking at Ben, not the camera. So I was trying to break in, or I was breaking in that 250cc engine, and I was just doing it on the run-in, Dad's run-in stand, which is basically a hydraulic pump, right? So I could load it up. And one thing I noticed is that just kind of beginning to, once it got some heat in it, was bringing up and making some sweeps with it, that at a low load setting, as it would rev up, I couldn't even get it to full throttle, and it would start cutting the ignition. I was like, something's weird, and scratching my head a little bit. Let me try putting more load to it and making a slower sweep, where I couldn't get beyond 7,000 RPM on that thing without any load on it, really. I can go to 9,200 RPM with load on it. It's EFI, and it's got a Delphi system on it. Do you think there's some kind of math in there that if it's accelerating too quickly, that it starts to cut the ignition? I mean, it didn't sound like a rev limit, but it was like weird.
My gut tells me you probably had more of a fuel delivery problem than an ignition one. And the reason I say that is when you try to rev on the dyno really slowly, you typically have to open the throttle very, very slightly, right? And so, because if you just whack the throttle wide open, it'll run away from you. Well, what happens is most people, including the OEMs, don't or can't spend a lot of time calibrating the engine at very high engine speeds with very low throttle settings, because you typically don't have enough engine power there to overcome the friction of the engine. So they have to motor the engine to even get it there, right? So what I've observed, especially doing that exact same thing on a lot of our engines, is that when you have, 5 or 6 or 7 or 8% throttle opening, but the engine zooms up because there's no load on it, it will typically get very low manifold pressure. And when that happens, the ECU will then calculate a very low air density and really draw back the amount of fuel it will supply the engine. And so I will see this all the time where guys will try to creep up the throttle opening and it'll pop and bang and misfire and run rough. And they go, man, it never did that when I had a carburetor. I'm like, well, your carburetor was giving it enough fuel for that application. So if you go down to the bottom end of your fuel table and you add some fuel in there, I'd be willing to bet Keith's salary next week that it runs smoother that way.
I knew I was thinking about this yesterday. It's like, wait, I'm going to hold that question. I'll see Ben tomorrow, and I'll ask Ben.
Glad you did. That's cool.
Yeah.
Awesome. Hey, guys, let's just take 2 secs. We've got some pretty awesome prizes to give away here real quick. Like I know Ben's got a really cool prize. So, Steve, what I'm going to do, I'm going to go back to you for just a minute, and let's give away the rest of that stuff, and then we'll go right back into the question and answer.
Sounds good, Rob. Okay, what we got, Ben has donated a online course gift certificate worth $349, and he's got a special code for that, and it's a one-time use. And what I'll do is, Ben, I'll pick the name, and then what we'll do is we'll just get you guys in contact together, and you can kind of walk them through the process or whatever needs to be done.
Yeah, great.
All righty, so we're going to pick the name here. Jerry Roberts.
All right,
so Jerry, we got your email address here, so probably next week we'll get everybody their information on their prizes and stuff and get that out to you guys.
And like I said, while that voucher code is for a specific group of our online training, which has been very popular lately with the COVID, if Jerry, if you decide you want to use it on something else, just let me know and we'll apply the value to whatever else you want. Enjoy it.
Okay, and then we also got a a Total Seal $100 gift certificate. And let's see, the winner of that is Tim McCormick. So Tim, will get that information out to you regarding your Total Seal $100 gift certificate. And we got an AERA hoodie here. And let's see, that winner will be Ronnie Stidham. So Ronnie, we got a hoodie coming your way, so we'll get to you on some sizes and get that taken care of. And let's see, we got another prize here, an AERA soft-sided cooler. And that is going to go to Hank Coburn. Hank will get that together and get that sent out to you. And we have one last prize. We have another $100 gift certificate from Total Seal. And that prize is going to go to Jeff Baldwin. So Jeff will get that together for you and get everything out to you. All right, Rob, I'll turn it back to you.
Sure. Yeah, no, thanks. Some good prizes there. So just going to go through, yeah, we've got questions that are still coming in. So let's go to a couple here. Keith, this one's going to be for you. What grit flex hone would I use for a nitrated top ring on an OEM iron block and leave a plateau finish for the final stage?
Well, that one's kind of a tough. I mean, the ball hone is really made for plateau honing. Its function really is to deglaze the cylinder or plateau after a rigid stone. A nitrated top ring has no coating. It's just a hardened steel ring. So again, kind of like we were talking about, it has no ability to hold oil. So my recommendation there is to kind of two-step it. I'd probably go in with a rigid hone, maybe a 220 to 280 on the rigid, give it a couple strokes just to, again, lay that valley and get that RVK back in. Then come back in with a ball hone, about a 320 grit, half dozen strokes. And that should give you some valley for oil retention and knock the tops down, get that plateau.
Super. Thanks, Keith.
Welcome.
Alrighty, we have a question for Billy Godbold here. And the question is, the gentleman is interested in how using a positive displacement blower influenced choice of intake closing event.
There's the intake opening or closing?
Closing.
Okay. Intake closing, you know, on the intake events, the positive displacement blowers are really interesting on the intake opening. Intake closing is a little bit interesting because it depends on the port geometry that's going on. You know, if you look at a lot of positive displacement motors, whether it's a top fuel motor or something like the Mitsubishi 4G63, you know, a lot of these things have really short ports that the port's really not wave tuned. It's just sort of there. And in that case, you don't have to have as late of a closing as you'd think. But if you take a positive displacement blower and you can have a longer intake runner on it, you know, Edelbrock's a sister company to ours, and they do a pretty good job on their positive displacement blowers of actually making a fairly decent intake manifold with the blower. The better the intake manifold is with the blower, the longer runner, the better that's done. Then you can have the intake closing very much like you'd expect with a normally aspirated. Now, on a positive displacement application on the intake, the opening side actually is more sensitive to the closing as far as what people often get wrong. What I mean there is, like, if you take a guy who has a 4-liter blower on an LS, he may open the valve absolutely as soon as he can and not crash in the piston. It's always, the earlier you can get it, it's always going to flow more air. Especially say if he's making 1,000 horsepower. But he's got 25, you look at the compressor map on that blower, it's a 2,500 horsepower compressor map. You get into NHRA factory shootout, that compressor map, you're scratching your head going, that thing might make 1,500 horsepower. And you got to make 1,500 horsepower to be competitive. So you can't open the valve so early that 300 horsepower go through during overlap. So the intake opening on positive displacement blowers, very sensitive to the size of blower. For a given RPM, those two applications, though, would absolutely have the same intake closing. So if you're running a Coyote and super stock and a Coyote and stock eliminator with a blower, even though one blower is twice as big as the other, the intake closing will be the same. Same thing if you had a 9,500 RPM LS had a 4-liter blower and a 2.3 liter, the intake closing would be the same as long as the runner length was the same. But the intake opening would be very different between the small blower and the big blower because of the compressor map, and you're really just running out of, you can't waste any air with a small blower. Ben, did I do that okay?
That was pretty good, buddy. I was thinking that.
All right. Question for Ben. When changing from a Dominator carburetor to a Sniper, will the intake manifold need to be modified as far as plenum volume and cross-sectional area of the runners to get the best performance?
So the plenum volume and cross-sectional area, let's talk about it in two different things. So a cross-sectional area of the runner is really there to feed the engine what it needs. So the area is about, total airflow, and the length is about the resonant tuning. So really you're not going to change that whether you have a Sniper, EFI, or a Dominator. The biggest thing that we saw was on a carbureted engine, we typically make the intake manifold so you can separate the top and you can make plates in there to space it. And we'd have, half a dozen different spacer plates because you really got to play with how much plenum volume there is. So the plenum acts as like a reservoir for airflow to be able to feed the runners when the cylinder demand gets higher and higher. The problem is if you make that reservoir too large, then you can't adequately create a large enough pressure differential across the booster and the carburetor to draw the fuel out. And so if you get that spacer too small, you kind of choke the engine for airflow. And if you get it too big, then you can't deliver the fuel the way you want it. So in a carburetor engine, that plenum volume is very sensitive. Typically somewhere between about 100 and about 102 or 3% of the engine's displacement is a good plenum volume to start with. So if I got a 350 cubic inch engine, I want my plenum volume to be somewhere around 350 or just a little bit more cubic inches of plenum volume. Now, when we move to the Sniper, because you get rid of the Venturi, and B, we no longer need that signal length, signal strength. Things like block deck height, which used to be a huge issue for these engines, is not. So what I'm getting at here is take a pro stock engine, for example, the deck height's critical because the length of the runner primarily dictates the resonant tuning at the RPM they need it to be. So if you want to peak at 10,500 RPM, the port length is X and your runner length has to be that length. Well, because the engine's a V, if I make the deck really tall out here and I have a really short runner to get it where I want, to connect those two in the middle, my plenum gets really big. Well, when the plenum gets really big, then I lose the signal to the carburetor and everything else. Well, by going to an EFI engine, we don't care about that signal to the booster Venturi anymore. So our plenum volume is able to be bigger than you would normally think it needs. That being said, we've done a bunch of testing and I haven't yet found any huge advantage to having more plenum volume than you actually need. So what we come down to is we can increase the airspeed through the butterfly by having a smaller butterfly diameter than we would typically have in a Dominator carburetor. So for example, you might have some fancy aftermarket Dominator carburetor with a 2,500, 2,600, 7, 2,800 throttle bore to be able to flow the 1,500 plus CFM it needs. But traditionally what happens is the airspeed through there is so terrible that you're only really able to trim the fuel delivery curve at one RPM range or another of the engine. And it gets worse when we have high transients. Billy, you talked about transients earlier. And I think one thing people miss is it's totally fine to do a 600 RPM per second dyno pull. We're going to start at a stabilized 8,000 and we're going to pull it to 10.5 at 600 RPMs per second. Problem is, that's not the way the engine goes down the drag strip. It goes through low gear at about 2,500 RPMs per second in a pro stock car, and that's as it's drawing the engine down because the clutch is locking up. In second gear, where everything's locked up, we might see 3,000, 3,200, even 3,400 RPMs per second of acceleration rate of the engine. That's nothing compared to the transients that the engine sees during a shift, when we might see negative 15,000 RPMs per second when you go from 10,500 to 9,000 RPM almost instantaneously. And so the reaction time that it takes for the carburetor to keep up and trim the fuel flow just can't happen. So you see wild swings in air fuel ratio as it goes down the drag strip. we've eliminated to a large extent that with the EFI systems by using higher airspeed through the throttle blades, because we can use a 250 or a 300 size throttle blade and get the same total CFM that we used to have a 6 or 700 to get. So the plenum volume has a big effect on that with a carburetor, but not a huge effect with an EFI system. I hope that didn't ramble too much and go off the reservation there, but that's an area that we've spent a lot of time looking at.
Super, thanks, Ben.
Okay, our next question is for Lake. What's a good amount of zinc in parts per million for flat tappet camshafts and mild performance motors, say in the 450, 500 horsepower range?
Did Billy ask that?
No, he did not. This individual has heard 1,000 parts per million. What's your thoughts?
Well, if I want to be the smart ass, I'd say, well, what type of zinc are you talking about? I mean, there's zinc and pennies, and you put 1,000 pennies in there, and it's not going to lubricate very well. But I won't do that though. The best type of ZDP for flat tappet camshafts, as we learned working together with Billy, is the secondary ZDP. So the secondary type of ZDP is the best, and we saw really good results around 1,200 to 1,500 ppm of ZDP. That's what that range, not for break-in, not for break-in. For break-in, we actually saw pretty good results from anywhere from around 1,800 to up to 2,800. That there is pretty forgiving in that range. If you get below that, things weren't good. You get above 2,800, things started to go away. There's a curve. I can actually draw it out if somebody really wants to see it, but they had to tell me before I go grab my pen and paper back here and draw it. There's at low levels of ZDP, wear is very high. As you start adding ZDP, wear decreases, and then as you add more ZDP to a point where it takes back off again, it increases, kind of like the Strybeck curve we saw. So really, you want to be in that optimal range. That 1,800 to 28 of secondary is what's ideal for break-in. Past break-in, you want to be in that 1,200 to 1,500 range. That works really good for non-coated flat tappet deals and stuff like that.
Perfect. Thank you.
No problem.
All right.
I just laugh because there's so much more going on than just that the people think that that's the deal, and it's just not. There's so much more going on to the chemistry.
So Lake, if you want to get them back, ask what's the right LSA for an LS engine, right?
You're number one.
One thing I want to say is that until like 10 minutes ago, I had no idea that there are people who had asked me questions privately, and I haven't answered them yet. So I'm sorry.
I didn't know that either. Maybe I have questions.
I will get to them. I had no idea there was all these questions, and I wasn't ignoring you. I just didn't know they were there. So.
No worries. All right, Keith, this one's for you. How thin of a ring can you still gas port?
We're able to take them down to, at this point, we've done as thin as 0.6 millimeter.
Okay, all right, thank you.
Yes, you want those, they're good.
Yeah, really well. As a matter of fact, in between sessions, just sold some gas ported top rings to a gentleman with a Subaru that Lake's been in contact with. And I know they're going to do a great job for me. So yeah, it's thin as 0.6 mil so far. Of course, the size of the port changes, the depth. How many are in there, of course, change, of course, the size of the board, thickness of the ring. We have different ratios depending on what size it is. But yeah, like I said, as thin as 0.6.
Okay, thank you.
Billy,
Mm-hmm.
Can you explain idle quality and how duration versus LSA affects it?
All right, well, idle quality is going to have to do with that overlap triangle that we showed graphs of. Now, the thing that there used to be this big debate, and the whole idea was it overlap duration that made the issue, or was it the area under the curve, the inch degree squared? What's the area under this overlap curve? And the answer is both of those matter, and there's more to it than that. Because you could have two triangles, overlap triangles, that had the same area under the curve and the same events, but had a different shape. So if you imagine a triangle like this, if I skew it this way and skew it that way, I've still got the same area, but I've changed where it's located. And so not only is it overlap area, but it's where is the area. We know if we put a lot of that area too far back, that we can get some really weird stuff going on. But the shape of the intake opening and the shape of the exhaust closing, we did a camshaft, a CARB approved camshaft for an LS, and when they took it to the SEMA garage and tested at the emissions lab, it actually was more overlap duration, more overlap area, but it was, I think, about 15% lower emissions than stock. And we're given 10 on the other side. So we were 25% lower emissions than we needed to be during startup before the cats lit. And I was kind of proud of that. So there's some things you can do with shape of overlap that change that misfire. And that's your major thing that you're seeing with, with the lope and the idle and everything like that, but also the carb stuff. So I wish it was as simple as, it can be 48 degrees at 6 thousandths. Okay, that's any number, or it can be this inch degree. It's really, really interesting how engines behave. And then the rod to stroke ratios come into play, and compression comes into play, and even how the port layout. A Hemi head is different than a wedge head, and a pent roof is different from a splayed valve. So every different combustion chamber, the valve angles can play into it. It's amazing the valve angles relative to one another, and the seat angles can play into it. The steeper exhaust seat can handle more overlap. There's some pretty bizarre. That's a much deeper question than probably the person thought. If you'd asked me 20 years ago, I would have given you a really simple, direct answer, and I would have been wrong.
Great, thank you.
All right, next one's for Ben. Can you please discuss in detail the proper grounding required for both steel body and fiberglass body vehicles regarding EFI systems?
Oh, maybe that's a tough one. Let me see if I can clear my screen first. So the grounding requirement isn't really any different for steel versus fiberglass body. You still need a clean, good path to ground. The only difference is it's harder to find that on a fiberglass bodied car. So traditionally, you're going to have some kind of ECU source that goes directly to the battery. A lot of guys want to cheat and go, well, I'll put this, battery lug here on the frame, and then I'll jump from there to the battery and whatever. And you can certainly get away with it, but more often than not, things crop up because of issues like that. Another big one is to make sure that you are tying the engine. A lot of guys want to tie the two cylinder heads together, and then from there, like a daisy chain, directly to a good clean ground source on the chassis. So, those are some things. The biggest one that gets missed more than anything else, though, is earlier I showed the guys these really high-powered, what they call smart coils. Lots and lots of companies are buying them and using them. They're typically made by either Mercury Marine or some knockoff Chinese place that's making them look the same and then selling them cheaper. But my point is, there's an extra ground wire on these that people often ask about and go, what's that for? It says it needs to be grounded to the cylinder head. Why do I care? And they'll ground them somewhere else, and it has caused all kinds of problems. So we need a direct high current ground path from these coils directly to the cylinder heads, regardless if it's a tube chassis car or a stock chassis, a vehicle or whatever. Grounding is one of those things that's always important, and it's always missed. Doesn't matter what kind of car you have, the cleaner the path can be. And what I mean by that is the less breaks in the wire, the less connectors you're using along the way, and less interruptions between the thing you're actually trying to ground and the actual negative terminal on the battery, the better off you're going to be in the long run.
Super, thanks, Ben.
Sure.
Okay, I got a question for Lake. Lake, can you please provide an example of the difference in viscosity between the aforementioned 6,000 RPM engine and the 11,000 RPM engine? what is a typical oil viscosity in each?
Oh, cool. I was just actually answering that question. That
I
guy
just saw
privately,
you
bro.
answer.
Here's everybody. That's what I was doing over here. I wasn't ignoring. Okay, so can you show me? No, we want to keep this place where everybody can see everybody. So an oil without polymers, okay, base oil isn't going to change viscosity with any change in RPM. So the viscosity is going to be the same. Remember, Stradbeck is viscosity times speed divided by load. So if it's a straight base oil with no polymers added, that viscosity is going to be the same even with increased RPM, increased speed. So what will happen is from say 6,000 RPM to 11,000 RPM, the film thickness will increase. The viscosity, which is resistance to flow, that's I think a lot of people think viscosity and they think thickness, and that's not the case. Viscosity is just a measure of resistance to flow. The more resistance to flow, the greater the speed. Those combined together, greater film thickness, thicker hydrodynamic wedge. So that's what you'll see. Now, the other slide I had up where we showed the shear thinning, when you add polymers to the oil, those polymers are like rubber bands, right? You stretch it out. What happens to the section you stretch? It gets thinner. So depending upon the type of polymer and the amount of polymer, the oil can shear thin to basically try to maintain that same film thickness, even at higher RPM. That way you don't give up on horsepower. So that's the kind of idea, so that you can not only adjust, say, the SAE viscosity, you're also changing how the polymer thins. Ben, I'm thinking about your small block Ford, and we don't know how much power that oil change made, but going from, say, a 530 with one type of polymer, an amount of polymer, to a 520 with a different type of polymer and amount of polymer, saw a difference in how much power it made, especially up top, and that was using both of those levers there to improve efficiency.
Great, thank you, Lake.
Elaborate on what he saw there. That's fine.
Well, I was trying to think, like, what do I know that you don't? But it's rarely very
Lots.
much. But, we did try a bunch of different oils on that engine, both on the Spinal Tap project, and like everything else, everything you do, you learn from, and it gets applied to the next stuff. And so the Ford engine ended up benefiting from all the stuff we learned on Spinal Tap, and some of that was oil. And I think we tried some 30 weight stuff when we were breaking it in. We were trying a couple of different 520s, and I think we ran some 0W2 in that as well. And you're looking for every advantage you can find. We played with oil pressures, we played with oil flow, which is really the same thing based on the way we did it. But we were changing the springs in that engine for the oil pump bypass, the overflow. And yeah, the oil absolutely made a difference. The question that was in my mind and probably yours and everyone else too is, well, did we give up any durability or reliability for that power? And so after we'd made about 20, which is a giant number of runs on the dyno for an engine like that. Typically those engines only make 2 or 3 and they go in the box and go to the customer, So after we'd made about 18 or 20 passes with, I think, 3 different oils, we pulled it off the dyno and we took it down and we're like, oh gosh, what are we going to see? And to be honest with you, we just put it right back together with the same bearings and everything, and it was perfect, and we just kept right on running it. So all of them provided the required protection that we needed. But there was definitely some changes in power between 0 to 520, 520 with chemistry and 30 weight. So I think probably on that engine we're probably talking just barely into double digits. We're talking singles most of the time, but the fact that you could change oil and find 5 to 7 horsepower is unbelievable in an engine where we sometimes spend weeks looking for 2.
All right, super. Keith, I have another one for you. This gentleman's asked, Ring gaps for turbo blower application. Is there a rule of thumb, such as so many thousandths per inch of bore per inch of boost?
Really kind of comes back to what we talked about earlier, tune-up. As a general rule of thumb, in most mild applications, we're not talking, 70 pound of boost on nitro, that kind of thing. You're going to run about just a 6,000ths per inch of bore is a general rule. That's a nice safe place to be, top and second ring for most applications. Really comes back to tune-up. I have guys that run very, very high boost levels that can surprisingly run very tight end gaps, but they have they're very, very conservative on their tune-up. They just don't hurt parts. They're not knocking head gaskets out of it. They're not killing plugs. They're just very conservative. So as a general rule, about 6.5 thousandths per inch of bore, top and second for most what I call general applications. You get into the extremes, again, 70 pound of boost on nitro, that kind of thing. You may be as much as 8 thousandths per inch of bore, just depending on how it's tuned. Like we talked about before, kind of look at the rings coming back out of the engine. Look at how they look. Check your end gaps. The engine's kind of again, like the, Oscar and the dog whisperer, it's talking to you. If you're paying attention to everything coming out, look at the gaps, look to see if you see any budding signs on them, record all that data. If it comes out, you don't see any budding, next time you build it, tighten it up a couple thousandths. You probably get away with a little tighter gap. If you're seeing those little shiny witness marks on the end gap, go a couple thousandths bigger. But it's really about observing everything coming out. How do the rings look? How's the free gap? Do you see any signs of budding in the rings? But again, as a general rule, about 6.5 thousandths per inch of bore will generally get it.
So Keith, I got something I want to ask in relation to that same thing. So we don't get to play with a lot of, this probably sounds terrible, but we don't get to play with a lot of normal like stock stuff here. Everything we do is typically super high end and racy, and we tend to chase the groove to ring relationship a lot. As you and I have talked about this kind of stuff a ton, and ring gap, and the cylinder finish, and Lake and I worked on all kinds of stuff. But one of the questions that's been rolling around in my head for a while is, how much relationship is there to temperature that the ring gets, which we know is directly proportional to ring growth, between the piston design, not design, but makeup, a 309 hyper-eutectic alloy versus a 4032 versus a 2618. So we know thermally a 2618 grows way more than, say, a hyper-eutectic 309. So how does that affect a guy's ring gap and sort of ring to groove clearance? What do you guys do differently for that stuff?
Well, as you stated, the hypers, the downside of the hyper is, it's brittle, but as far as stability, it's phenomenal. It's absolutely fantastic stuff. If it wasn't so brittle, it just doesn't grow. It's stable as hell. The grooves don't move around. 2618s, 4032s. Like we say, they like to move around a lot more than the hypers do. So the hypers, you can actually run surprisingly tight ring-to-ring groove clearances. As far as end gap goes, don't really see a big difference end gap material to material. That's more about the actual ring temperature expansion of the ring. But ring-to-ring groove, that's definitely where you see the difference. The hypers, you can run surprisingly tight ring-to-ring groove clearances. The 18s and the 4032s grow a lot more. So you can obviously have to adjust the gaps for that. But I definitely like the hyper. You can run a lot tighter.
Yeah, cool.
Okay.
Super, thanks.
Question for Billy. When selecting a camshaft, which is the more significant spec to look at? Advertised duration or duration at 50?
Well, definitely the duration at 50. And the reason that is because cam designers lie. There's not a like hard and fast SAE spec that you can take somebody behind the woodshed for. If you say it's 288 advertised, and it's really 289 or 290 or 292 at 20, that's just the advertised spec. So really the advertised specs, if it's within a cam company and it's within the same generation of guy who is doing it, they might be halfway trustworthy. But if you're going to take cam manufacturer A and cam manufacturer B and look at advertising, you can't really tell about what's going to do what. And one of the things that we're starting to understand is, like when I showed you that, when I was running through at the very end, I showed some power differences at that test that Jeff Smith did with Engine Labs. And he was shocked because the 6,000 spec on the camshaft that made more torque and more power, more everything, it was bigger advertised duration, even though they're the same at 50. So normally you'd think, okay, if it's bigger at advertised, it's going to be a poochier cam, it's going to make less torque, it's going to make less power, it's going to be worse everywhere. But what you can't see is how that split of the advertised duration is, meaning that it was slower opening and faster closing. And that early opening side that we added to advertising, we had 4 degrees there, and it did absolutely nothing negative. And that sort of plays back into what we talked about, the overlap triangle. But when you look at cams, they're all the same duration at 50. If they're degreed in with the same valve points, they should make peak torque and peak power. Where they peak should be within a few hundred RPM of one another. Now, how much they make, that can vary, but those 50 thousandths valve timing events, that exhaust opening, intake opening, exhaust closing, intake closing, those 4 events, if those events at 50 thousandths lift are about the same, where it makes power will be pretty close to the same spot. And I did like, before I miss it, the thing that Keith's saying about listen to your engine, whether it's something where it's motor oils, your EFI system, your camshaft, your valve events, or your rings, or your pistons, or your bore. It's amazing how much engines want to do the right thing. Half the time, we're trying to hold on to the reins so hard that we're trying to drive them someplace they don't want to be. If you can listen to your engine and really get to pay attention to it and get to know it well, there's a lot of crazy things that it's trying to tell you, and the great engine builders get that. And guys like us sort of pick it up along the way just over time.
I have a bunch of valve strings that would agree with that.
Yep. I told somebody about that low shot being like the happy wife, happy life. You know, if you're going to ask a whole lot about the valve spring later, you better treat it nice early.
Yeah.
You know, I've tried that with cam designs. I've tried that in my marriage. Being good on the front end is a good idea regardless.
Backing up brownie points.
Yep.
Okay. We do have one live question here that is for Lake. So Mike, I believe is his name. We'll turn it over to you.
You there, Mike? Caller, you're on the air.
Well, looks like we're having technical difficulties with that again, but he did type a question.
Temperature?
Yes.
Am I on now? Okay,
Yep.
sorry.
Yeah.
We got him.
This is a really simple, basic question. We're talking about 220 degrees oil temperature.
Okay.
Where is the ideal place to measure that?
Ideal place to measure that is what oil in. So oil going into the main oil gallery, that's what the engine is going to see. So that's what you really want to where you want to measure. If you measure on the oil out, it will be quite a bit hotter, and that's okay. And that, you know, it's fine for it to be hotter on the way out because oil's a coolant. It's not just a lubricant. You know, one of the questions I had answered was, do you ever see an engine without oil? No, because this oil is not just a lubricant, it's also a coolant. And, you know, so it's important to have that ability to carry away the heat. So really, the critical temperature you want to look at is the oil going into the engine. I would rather use that as your point to measure from.
Okay. I've got a question. This one will be for Keith. It's basically from a previously asked question by someone else, but they're asking how much heat from the ring is absorbed by the piston? What are the various methods of ring temp control? Is it oil, cylinder walls, piston material? What's your feeling on that one?
Again, cooling of the underside of the piston, as far as, you know, ideally you want all the heat to go back through the ring, get it out of the piston, into the ring, into the wall, out to the water. But the most positive thing you can have as far as effect on the piston is oil underneath the piston. Oil is a coolant. If you look at the modern race engine, NASCAR in particular, last time, I don't get to look at RO7s a lot, but the last time I looked at an RO7, it had 5 oil jets underneath there to use as a cooling system for the piston. So oil is the most common coolant for the piston. There are diesel applications out there today that actually have pathways through the underneath side of the dome, underneath the bottom side. This one's kind of got a hole in it, but through the actual pin, comes up around the side of the pin, around and back down as an exit to actually get oil underneath the bottom side of the dome. The piston's actually hollow, using that oil as a coolant. So oil is that's your best line of defense to cool the piston. Hopefully that answers the question.
Super. Yeah, thank you.
Actually, I'll go one up on you, Keith. If somebody
Thanks,
really
brother.
wants to know,
There you go.
there's a book called Piston Ring Tribology, and it actually shows Keith's example of that diesel ring that's doing it. And in this thing, it actually says, and it's different research papers, it says that the majority of the cooling or the heat transfer out of the piston is through the oil, not through the piston ring. And one thing we did at Gibbs, we actually worked on the selection of base oil that actually had the highest specific heat capacity to pull heat not only from the pistons, but also from the valve springs, because that's another big source of heat in the engine. And anybody that has a Spintron knows that even without combustion, you can get the oil pretty hot, can't you, Billy?
Oh, you can make bad smells from cheap oils. One of the things that people don't really think about too, if you take it something like what Duttweiler runs at the Salt Flats, in the Speed Demon, how much fuel he runs through the engine to cool the piston. There's a lot of, you think the tune-up's conservative, but that's running on methanol, so he's running a lot of fuel through there. I'm pretty sure it's so that it makes it to the 5 mile mark.
Yeah, heater vaporization works really good to cool things
Exactly.
down.
When you're putting, if you looked at his fuel pumps, looked at his injectors, and did some quick math, he's not making that much horsepower. Yeah.
Just to touch real quick on what Billy said, in a different world, sprint car engines, the amount of fuel that goes through those things is insane. And as you said, are we getting the energy out of it? No, but we can run a smaller radiator and a smaller oil cooler, which means less weight out on the nose of the car. And those guys are all about where the weight's at. So we'll pour fuel through it, create some kind of ring seal havoc to take 2 pounds off the nose of the car. But that's
wait.
that's what they do.
You mean a crew chief would intentionally make the engine run worse than it's designed to do just to make the car handle better? No, never happened. That won't
Inconceivable.
Sunday.
Keep using that word.
We should have Doug Yates in here, right? It's crazy to hear Doug talk about how just insane, they run these cup engines anymore just for the aero benefit. That engine's not running anywhere near what its real potential is in terms of, but because of the having to accommodate for the aero part.
Yeah, I mean, think about like Keith was talking about those piston squirters. You almost couldn't run one of those cup engines without those, but in a drag race engine, we take them out. We don't want that because that's windage and oil that's flying around in the crankcase. And it's like in the cup stuff, you got to finish or you can't win. And we don't have to go 500 miles. We have to go, 1,320 feet. So, the application is always the king, you know what I mean? Like whether it's Billy choosing a lobe shape, it's a valve spring, it's you guys with rings or oil or whatever, application matters almost more than anything else.
Yeah, there's a lot of specific heat in those components. So, that piston's absorbing heat. On a pro stocker, if you're at wide open throttle by more than 7 seconds, you've lost anyway.
That's a good point. And it all comes down to the engine building. Damn, if we just didn't have to put them in the cars, we could build the perfect piece.
Right.
Exactly.
Okay, we got time for one last question. And this is actually it says Billy or Ben, but we can do Billy and Ben. On a valve spring shape, conventional or Beehive, which is better for a higher RPM engine?
Conical?
Well, I've never seen a Beehive work at real high RPM. We tried to make a Beehive spring for a pro stocker, and I believe it got to 10,000 RPM, and Elvis left the building. There was it was a Beehive outer and a cylindrical inner, and the Beehive broke and sent shards through it. So and that was the biggest wire Beehive. That's the biggest Beehive we'd ever made. But generally, the Beehive technology is about minimizing mass and letting you do things you normally can't do in a lower RPM, lower lift deal. About the highest RPM Beehives I know are probably used in like a Ford Coyote deal, and probably about, what would you say, Ben, for a factory shootout car, a little over 10,000 RPM?
Yeah, so on the Ford stuff that I worked on, they're 10.1, 10.2, something like that is what the Fords go to. Yep.
But if you look at the NHRA Pro Stock bike, they run a real lightweight dual. Now, if we could make a conical spring for a Pro Stock bike or a Coyote, I think it would be a better piece. But, setting up to run a conical, you probably are, to make the first conical spring, you probably have tens or more thousands of dollars in setting up the equipment to grind it, because it's hard to hold a conical spring straight in a grinder. So that's why you don't see short run conicals. You've got to really commit to make a few thousand springs.
So Billy, we see a lot of guys that ask questions here. I think there's a misconception around the industry about the difference between a conical and a Beehive. Everybody just assumes they're the same,
Yeah.
But tell us a little bit about why they're different.
Well, a Beehive really was just to take some weight off the top of it, so you can make the retainer light. But basically, the Beehive doesn't nest, and it's got 2/3 of a Beehive is a cylindrical spring. A conical spring, every coil is different, and a conical spring, every coil nests. So a Beehive really is kind of not a conical, and it's not a cylindrical. It's sort of a hybrid. But the nice thing about Beehive, it's much easier to make, because you do have that 2/3 of it that's cylindrical that makes it quite easy to hold in the grinders and everything like that. So if you ask somebody at a spring manufacturing plant, do they want to make a cylindrical, a Beehive, or a conical? They want to make the cylindrical. They'll make the Beehive, but you start talking conicals and you get called names and stuff thrown at you and everything, and eventually you just have to give them scooters, front of the check, back of the check speech, and then they will kind of go for it.
But obviously there's huge benefits that we've been learning about with the conicals.
Yeah, if you can make it and you get it right, and like we talked about, you saw my slide how I had that spring. You've seen them in real life, where you have to go in there, and when you do a conical, you have to make sure each spring is sharing its amount of the load that it can handle, that each coil is equally stressed. And that type of research in it, you just can't really throw one together.
Right.
That's why the number of SKUs number of part numbers is so small for conicals.
So when just since we're talking about it, when we first started doing the conical stuff, we didn't have a lot of the low shock lobes yet, and so they didn't like that very much. Do the traditional cylindrical and Beehives fare better without a low shock lobe? I mean, we've obviously had the last 3-4 years, giant strides, but
a Beehive probably is more like a conical in that it would like to be treated a little nicer on the opening. Some of the big triple springs you saw in NHRA Pro Stock, 1,500-pound open guys, and even the 1,200+ pound duals you see in drag racing, those things are kind of like big gorillas. And if you can imagine, you can slap those pretty hard without totally pissing them off, because they weigh so much, you can't really get them excited. You know what I mean? So they're not as concerned about the low shock. As you start going to lightweight, NASCAR style NASCAR style duals, you start looking at the dual springs they run in today's modern dirt track engines and World of Outlaw type stuff. Those small diameter duals, they're very sensitive, and conicals are very sensitive. But the really big, heavy, old school stuff, it jiggles regardless. So, it's just, you slap it, it jiggles a little bit more. Kind of like a big offensive tackle named Fred. You just hit him and he goes, okay.
Great. Well, I just want to thank all you four gentlemen, Ben, Billy, Keith, and Lake, taking the time out today, doing this super webinar for us. It turned out fantastic. We did it with no hitches, which is great. We had no technical difficulties. So again, I want to thank you guys for taking the time out of your day and doing this for our group that was in attendance today.
Privileged to be here.
Yeah, thank you.
Yeah.
It is great.
so
These are good friends of mine, and I really enjoyed being on this panel today. These are wonderful men. It's enjoyable to be talking with them.
I
Yes.
appreciate being in the company of these guys. Like I said, truly best at what they do, and I can only thank all of them for letting me be part of this.
Yeah, and I just want to say thank you guys for all your promotion and helping out with this. I mean, this was put together kind of a little bit at the last minute, and you guys made it a huge success. So again, very appreciative. And if you if there's any questions, I mean, anybody out there that still has questions, I mean, all of these guys are very accessible. So by all means, please feel free to reach out to them and ask any questions that you've got. And what we'll do now is I'm going to go over to Amanda here real quick. She's just going to wind things up and tell everybody how you can contact us and how you can do the survey. So guys, you have a good Friday night. You have a good rest of your weekend. And I know Ben and Keith, you probably got a couple hours left to put out yet, but the rest of us will, we're going to have a beer. So thank you very much, guys. Appreciate it.
Hey, I'm in. It's only
I was saying while we were talking, so it doesn't matter. We're even.
All right, thanks again, everybody. For those of you who will be signing off here, you will get a survey that pops up. Please take a moment and fill that out. Let us know how we did. If you have any questions for any of our presenters, you can pop those in there. Also, tomorrow you will receive a link to the recording of today's super webinar. That is yours to use as you would like. Go ahead and forward that on to other people or view it. If you had to duck out for a little bit, you can go ahead and view whatever you missed. And then lastly, if you need to reach anyone here on the AERA team, you can get a hold of us at 815-526-7600, or you can email myself at amanda@aera.org. Or even if you reply to any of the emails you get from GoToWebinar, those come to me as well. So if you have any other questions for anyone or need to get a hold of us for any reason, you can go ahead and do that, and I can forward them on as needed. So thank you again, everyone, and we hope you all have a great weekend.